We're going to start recording now. Hello and welcome to Math Divulged Week 11 Fundamentals. This Saturday we'll be talking about voting schemes. As you probably all know, 2020 is an election year and there is a lot of talk about what kind of voting schemes are good, what are their advantages and disadvantages, and how they might affect the results of the US election. Now, this is a pretty extensive topic, so we will only touch the basics of it. But there's a couple methods we want to cover, stuff like first past the post, ranked choice voting, and a theory called arrows and possibility theorem. These are things that we're going to be covering today. So I'm Naveen, I'll be your teacher for today, and our TA is Andrew Kai. So let's get started. Suppose we have two candidates. We have candidate A and candidate B. So to put it in terms of US politics, let's say that candidate A is further left towards the spectrum. So this is be left and right. Hopefully that's pretty obvious. So candidate A is farther left, candidate B is farther right. And let's say that this is the center. Let's make an assumption that voters generally follow a bell curve. Something like this. That's not so neat, so we draw that. So let's say that this represents the general, where the ideas of voters are on the spectrum. So there's more people in the middle. Like over here, let's pick a neutral color. Let's say pick purple. Over here, it's largely moderate. This is our moderate area. As you move closer to an end of the spectrum, we have less people that follow these extreme ideologies, at least extreme with respect to the other, in respect to the moderate area. So over here, we have a far left ideology, and there's less people in the moderate. And over here, we have a farther right ideology. So even though most people tend to fall in this purple area, there are people that exist on almost all areas of the spectrum. Let's make another hypothetical. Let's say candidate A is located somewhere that is, let's say over here. Let's say that his or her ideology falls on that area. So let's draw a yellow line to represent that place. Let's say candidate B is a little bit more extreme right. So where would candidate B's ideology fall? Fall right here. Now voters tend to follow whichever candidate they most closely feel like represents their ideologies, right? So we can kind of draw a line right over here. Pick a different color. Let's choose let's just choose gray. So the midpoint of these two so this entire area right over here will likely vote for candidate A, and this entire area right here will likely vote for candidate B. Now we're assuming that the distribution of voters is symmetric. Now, there's a lot of assumptions, but this is a good introduction. So as you can see, the midpoint right here lies farther right of the political spectrum. Therefore, more voters will vote for person A. So that's just like a basic introduction as to what happens in a lot of elections. But what about the actual voting schemes themselves? So the US follows a program called First Past the Post. Now, what First Past the Post says is that you just add up the votes and whoever gets the most votes wins. Let's take the United States for an example. The United States follows an electoral college where 538 electoral votes are awarded based on who wins each state. So if you divide this by 2, you get 269 electoral votes. So whoever gets 270 electoral votes wins the election. And this is always true. And this is why you have sites like 270 to win. This is why you talk about the path to 270. This is what they refer to. So what are some disadvantages of this? The disadvantage of first past the post is, well, let's take our old example of the bell curve, right? Let's draw it again. But instead of having 2 candidates, we have 3. So we have candidate A, we have candidate B, it's more vibrant color, and candidate C. Let's draw some lines out here to see how they're going to vote. So candidate A will probably have around this much. So from here to here is candidate A's domain. What about candidate B? Candidate B, if there wasn't a spoiled candidate like candidate C, would have the rest of the political spectrum, thereby ensuring the win, because the midpoint is right about here. But since candidate C exists, we get another dividing line right about here. So now who wins? Candidate B gets this much, candidate C gets this much. So even though candidate A represents less of the political spectrum, candidate A will still win because C and B split the votes among themselves. The most famous example of something like this happening is probably the year 2000, where we had George W. Bush versus Al Gore. So this was a ridiculously close election. The entire election was decided 271 to 276 was the final score. So 271, 266. The state that decided the election was Florida this year, just barely going for Bush. Even though Gore actually won the popular vote. Like, he won more votes throughout the entire nation, but Bush still won because he won more electoral votes in more states. So why I say that there was a spoiler candidate? Because there was another candidate named Ralph Nader. And he belonged to the Green Party. And Ralph Nader, as the story goes, stole votes from Al Gore. So in the state of Florida, Ralph Nader served as candidate C, while Al Gore was candidate B. And George Bush won by like less than 1,000 votes, if I remember correctly. This is a pretty big controversy when it first happened. So that's one of the issues with first past the post. You get the possibility for these spoiler candidates. So what are some solutions to this? Another idea is ranked voting. So this is where you say you get your 3 candidates, A, B, and C, and you have to rank them from 1 to 3. Like, who would you rather see as president? So let's copy our spectrum from earlier. This might take a while. There you go. So if you're on someone on politically left of the spectrum, you would say you would want 1, 2, 3. 1, 2, 3, because that's who represents your vote. And this would probably be someone right over here. That's who this represents. Now, if you're at the midpoint, like if you're perfectly in the center, like this green voter over here, you would vote for B, and you would say A would be your second choice, B would be your first choice, and C would be your third choice. If you're just a little bit off center towards the right, so let's make a different color. Right over here, you would put B as your first choice, C as your second choice, and A as your third choice. Lastly, if you're over here, you would put C, then B, then A. And this is a little harder to count, but it still works. So what you do, so here's the procedure for ranked voting, which is also known as instant runoff voting. So first, you count up the number 1 choices. So figure out for how many candidates, so for each candidate, how many number 1 choice ballots do they have? And then if someone has the majority, they win. So that would be like our first example right here. In this case, when ranking 2 candidates, A would have the majority of number 1 candidate of choices. So what happens next? Let's say if someone does not get 50%, like you could easily have something like over here, you could have 40% choose A, say 35% chose B, and 25% chose C. Well, 25% chose C. What happens here? What you do is you eliminate the last place loser. So C is gone. So now your choices are between A and B. Should probably write that step down. And then you basically do another run through of the selection. How many would choose A? How many would choose B? And in this case, B would win because C is no longer in the picture. C would be erased. And in this case, B would win, more accurately representing the political spectrum. And you would just keep repeating this process until someone has 50% or more. So to recap, you ask voters to rank their choices, and we would get like 3, 2, 1, 1, 2, 3, 1, 3, 2, all sorts of wacky things. And then you eliminate the person in last place and keep going, keep running these rounds until there's a majority. It seems very complicated, right? However, there are other ways that also involve ranking. The next one we're going to cover is called the Borda count. If you guys have done Math League, you might have seen this word Borda used. Now what Borda is, it's pretty hard to explain. But you basically give like relative scores for each candidate. Like in Math League, you know that harder problems have a different Borda from easier problems. So at Borda, here's what will happen. So let's say you have a bunch of ballots like A, B, C, A, B, C, A, B, C, A, B, C, and you're gonna assign them, and let's generate some random votes. So 1, 2, 3, 2, 1, 3, 2, 1, 3, because we can have duplicates, and let's say 3, 1, 2. So what you do, you just add up all the rank numbers. So A, you get, so for A, B, C, for A, you get 1 plus 2 plus 2 plus 3 is equal to 8. For B, you get 2 plus 1 plus 1 plus 1. Oops, got confused there. Too many 1 pluses is equal to 5. And C is 3 plus 3 plus 3 plus 2, which is 11. Now, Borda, you take the lowest score, and that person's the winner. So in this case, B also wins. Now, this system is actually used. It's used in Slovenia, apparently. Now, finally, this is the last one we're going to talk about, like where you rank candidates, and there's a reason for that. And the last one is called the Condorcet method, or Condorcet. Now, what this method does is you run an election between every pair of candidates. So imagine like a rock, paper, scissors game. So you have A, B, C again. Let's put them in triangles. It's easier to visualize. So A, B, C. So A versus B, who wins? B versus C, who wins? A versus C, who wins? Now, if one candidate wins every single matchup, they win the election. And no government actually uses this. It's just a theoretical method, and there's a reason for this. I mentioned rock, paper, scissors earlier. So what if a rock, paper, scissors situation actually does exist? Like, for example, let's say A is rock, B is paper, C is scissors. Well, paper beats rock, so paper gets a point. Rock beats scissors, so rock gets a point. Scissors beats paper, so scissors gets a point. And we end up in a dead heat. There's no winner in the situation. So it doesn't always work. Now you can see that there's problems with each of these situations, right? In fact, there is a theorem that states that any system choosing that where you're ranking individuals that have 3 or more options. So like where you have candidates A, B, and C, and you have to rank them in some form. This theorem, Arrow's impossibility theorem, states that no electoral system can convert the ranked preferences of individuals into an actual ranking while also meeting a specific set of criteria. Now these criteria there are 4 of these. Let's go through them. The first one is unrestricted domain. So what unrestricted domain says is that all preferences of all voters are allowed. That's pretty straightforward to understand, right? So let's write that down. All preferences of all voters. So the next one we're going to talk about is non-dictatorship. So this says that the results of voting cannot mirror that of any single person's preferences without consideration of the other voters. And what this means is that there shouldn't be a single voter. Kenneth Arrow describes this as voter I, such that I always decides the election. So I vote for a candidate, candidate wins. If I doesn't vote for a candidate, candidate does not win. And this is non-dictatorship. There shouldn't be a single voter that sways the election. And blind voting systems with at least 2 voters automatically satisfies this. So that's not too much to worry about. The next one's a term you might have heard in econ. Like if you guys take economics classes, you guys might have heard about this. The next one is Pareto efficiency. This appeared on Decathlon earlier, if you've seen this before. So this is a situation where no individual person can improve the situation without making someone else be worse off. As an example, let's say we had a distribution of wealth that was 90 to 10. Just for an example. So neither of these people can make their situation better without making someone else worse off. That's what Pareto efficiency is. The last criteria is also known as IIA. And this is independence of irrelevant alternatives. So independence of irrelevant alternatives. So Kenneth Arrow defines this in terms of social choice as the social preferences between the alternatives X and Y depend only on the individual preferences between X and Y. So to make this a little bit more clear, let's go back to our spectrum over here. We have A and B, right? If we introduce a candidate C, which we did earlier, if someone prefers A to B, there should be no situation in where adding a candidate makes B preferable to A. So just to clarify, if we remove candidate C, if there is a hypothetical voter that prefers A over B, there shouldn't be the independence of irrelevant alternatives, or IIA states that there should not be a candidate that makes B preferable to A. So candidate C is irrelevant to the choice between A and B. So let's go back to Arrow's impossibility theorem. What this theorem states is that when there are 3 or more options, then any system that ranks candidates cannot meet all 4 of these criteria. And this is named Arrow's impossibility theorem after the economist and Nobel laureate Kenneth Arrow, who showed this theorem in his doctoral thesis. So Arrow himself said that what this theorem shows is that most systems are not going to work badly all of the time. All he proved is that all can work badly at times. There will be situations where each of these systems breaks. So it looks like we're kind of done, right? Like, what do we do if all ranked choice voting will have issues? Well, the supposed voting system is where you don't rank candidates. Instead of ranking them from like 1 to 3 or choosing a specific person, you have non-ranked systems. So one of them will be approval voting. So let's draw our spectrum again, just to demonstrate. And let's draw our candidates again. A, B, and C. So in approval voting, what we ask each voter, let's say there's a voter right here, and let's draw out the respective areas for each candidate. So we ask, what candidates do you approve of? And normally this would be a range, right? This will be a range, like say from here to here. And this person will say, I approve of candidates A and B. So their ballot will look like this. And there are variants of this. And whoever gets, in this case, whoever gets the most approvals wins. Just kind of similar to ranked choice. And a variant of this is score voting. So draw spectrum. And draw candidates. So we have our hypothetical voter again. And instead of asking them to list a range, like from here to here, we give everyone a score, not a ranking system, but a score. So let's say since this voter is kind of close to candidate A, this person will give them a score of like 8 out of 10 for A. The voter will give a score of 5 out of 10 for B and 2 out of 10 for C. And this is not a ranking because two candidates can have the same score. So these are all the voting alternatives that we're going to consider. And you just add up all the ratings, see who wins. Like whoever has the highest score. So let's investigate each of these methods in more detail. Obviously, with first past the post, we saw what the issue was, right? We can easily have a spoiler candidate that detracts votes from one side of the spectrum. A more recent example of this, actually, was the 2020 Democratic primaries. So if you guys were following the Democratic primaries, it was a pretty, there were a lot of candidates this election. At some point, there were like 20 candidates at one point. So in general, they fell between two lanes. We had considerably more progressive and more centrist because the Democratic Party tends to be left-wing in America. Now, the two biggest pieces, like the two biggest representatives of each side were Bernie Sanders and Joe Biden. Now, I must give a clarification. These labels of progressive and centrist may not be exactly true, but this was the public perception, which matters more than their actual like what they actually are when you're considering voting. So heading into Super Tuesday, Biden wasn't doing that well. And this is because the field looks something like this. You have Bernie over here, and he took up most of the progressive wing, along with Elizabeth Warren, which is somewhere more over here. But the centrist vote was being split, like the moderate vote. It was Joe Biden, Amy Klobuchar, Pete Buttigieg, and Michael Bloomberg. Tulsi Gabbard somewhere here, but she was largely irrelevant. So heading into Super Tuesday, we had a situation where Bernie Sanders might have won Super Tuesday just because there were less people dividing up the progressive vote compared to the centrist vote. But before Super Tuesday, like right before it, Amy Klobuchar and Pete Buttigieg actually dropped out. And Joe Biden basically had a comeback story where he decisively won Super Tuesday and won most of the states, including states that nobody expected him to win. So this was the opposite of the spoiler effect. And Amy Klobuchar, Pete Buttigieg likely saw that they were splitting up the vote, and to avoid the spoiler effect, they dropped out before Super Tuesday, allowing the moderate vote to consolidate around Joe Biden. And now he is the Democratic nominee and will be going against Donald Trump in November. So that's an example of first past the post and spoiler candidates in action. That's more recent and that more of you probably know, because I doubt any of you were alive in 2000. I wasn't alive back then, so that's pretty detached from reality for me. Ranked choice voting is actually not that widely used. It's used in Maine. Maine adopted instant runoff pretty recently. Like I believe it was in 2016. Give me a second, I'm just scrolling through the notes. So ranked voting, we see it in mostly local elections like San Francisco, Minneapolis, Portland, and Australia and Ireland use it in national elections. So one of the issues with ranked choice voting is it's not exactly a spoiler effect. There are other issues besides the spoiler effect that result from ranked choice voting. Let me see if I can draw out a good example, because this is really hard to visualize and draw out. Let me draw out a two-dimensional spectrum instead. Suppose we have a very far left candidate, and we have a moderate candidate, and we have a far right candidate. If you guys recognize where this is from, there is a great website which I will link in at the end of the meeting where a lot of this is from. And I honestly can't do this meeting without that visualization. But let's say that our voters are largely on, a spectrum like this. And what each of these indicates is like a density of voters. So this is very dense. This is moderately dense, and this is not dense at all. And this is where voters tend to fall. So in this case, the blue candidate, the far left candidate, would win, because in ranked choice voting, no one would win the first round, then the hexagon would be eliminated. And then the triangle will go against, sorry, hold up. All right, now that I got that settled, the hexagon will be eliminated, the triangle would go against a square, and since the blob of voters, it's not letting me select it at all. There you go. This blob of voters is closer to the triangle than to the square. So the triangle would win. But if you move this blob slowly up, what would happen is the square would be eliminated. And instead, you would be having a triangle against the hexagon. And this one's closer to the hexagon than to the triangle. So the hexagon would win, even though it was literally third place right before. So it's possible for a winning candidate to lose by becoming more popular. The voting block shifted towards the triangle because he got more popular, but lost as a result. Turns out this actually happened in 2009. The Burlington, Vermont mayor election so the winner, Bob Kiss, could have been defeated by raising him on some of the ballots. So this is an actual example where this happens, and mathematicians say this could happen around 15% of the time, which is 1 in every 7 elections, which is enough to shift like politics for a very long time. So this is the glitch that occurs when you have instant runoff voting or ranked choice voting. I won't go into the details of this, but just to give you an example of what happens with the other ones, the Borgia count has a reverse spoiler effect. So one bad candidate can help another bad candidate by moving closer. So it's the complete opposite of what you saw with first past the post. With Condorcet, we already talked about the rock, paper, scissors setting. So there'd be no winner. So all of these ranked systems have some kind of exploit, some kind of glitch that makes sure that it does not work perfectly. So some mathematicians got together and decided, what would happen? Like, what would be the best system of voting? So Warren D. Smith in 2000 ran 2.2 million simulations with 5 candidates, 200 voters, and 2 issues to see what would happen. And it turns out that score voting, which we saw over here, would result in the most fair election, the one where everyone is most satisfied. The ones that were closest were approval rating. Then you'd have the Borgia count, Condorcet, instant runoff or ranked choice, and first past the post. So the US actually uses one of the worst ones out there. And there's been pushes to change the US electoral system for a long time. Like recently, you might have heard talk about getting rid of the Electoral College. And I'll describe it because I feel like a lot of you are confused by that when I mentioned 538 electoral votes. Let me draw the US. I'm not actually going to draw the US because that is very messy and I'd like to not do that. But let's just draw a rectangle. And let's say we have 50 states, right? So 1, 2, 3, 4. So that's 5 columns. 1, 2, 3, 4. 1, 2, 3, 4. So there are 50 boxes representing 50 states. So what the Electoral College does is it assigns a certain number of electoral votes to each state, largely depending on its population. So for example, Alaska has 3. Hawaii has 4. And let's talk about some big states. California has 55. Texas has 38. Florida has 29. So does New York. With the Electoral College, there is a rule that no state can have less than 3 electoral votes. And what this means is that a lot of Midwest rural states, like Idaho, Nebraska, Kansas, like those kind of states, even though they have low populations, they are overrepresented. So if you guys pull up a map of the electoral map from 2016, you can see a wall of red in the Midwest. Actually, let me see if I can link one of those. Yeah, just pull up a map of 2016 election, and you'll see a lot of red. You'll see states like North Dakota, South Dakota, 3 votes, Montana, 3 votes, Wyoming, 3 votes. And you have a lot of these small states with 3, 4, 5, 6 votes. And then you'll have states like California, New York, Illinois with a lot of blue votes. So the way that these votes are distributed is that it's winner take all. So if you win the popular vote in New York, you take all 29 electoral votes. If you win the popular vote in Texas, you take all 38 electoral votes. If you win in California, you take all 55 electoral votes. There are only 2 exceptions to this rule. Maine and Nebraska do their own thing, and that's beyond the scope of this conversation because it gets very confusing if you're new to this. But you can see that a strategy for votes would be to focus on these big states, right? California goes reliably Democrat. New York goes reliably Democrat. Florida is a toss-up. Florida pretty much decides every election in most years. So it oscillates between red and blue. As we saw in 2000 between George W. Bush and Al Gore, the results of Florida decided the election. Texas normally votes reliably Republican, but this year might be an exception, and there is a focus in Texas for Democrats to come out and vote. And it's 38 votes, which could act. And last year the results were Clinton 232 and Trump 306. And Texas went red that time. If Texas flips, you get Clinton 270 and Trump 268. So if everything remained the same from last year, but Texas flipped, Clinton would be the president. And that's why you see talk about swing states so much. Swing states are ones that flip every year. States like Wyoming, they don't move. They're always Republican. California, always Democratic. New York, always Democratic. But these swing states, and I'll write down some of these in purple. Florida is one of them. Pennsylvania, which is 20. Ohio used to be a swing state. I'll still include it here. It's 18. Michigan is 16. I highly recommend that you pull up a map of the electoral map while you do this. And Wisconsin is 10. Arizona is 11. And these are like your classic swing states. Now, all of these change hands quite often. In 2016, Trump took all of these states. He won each of these swing states. As you saw with Texas, you only need 38 votes to flip. So if Clinton won, let's change it. Let's say Biden, right? Because he's the current 2020 nominee. If everything remained the same, but Biden flipped these 3 states, that would result in a dead heat. It would be, so he flipped Arizona, Wisconsin, Michigan. That would be 37 votes. And that would put them at 269 to 269. So that's a little bit of a tangent that we went on because there's not much else to talk about when it comes to voting schemes. Andrew, do you have any other topics you want to cover? Andrew, I can't hear you. Are you here? Paging Andrew. I think that's all we have to talk about this time around, though. So thank you all for coming. I know we ended a little bit early, but in regards to voting schemes, we pretty much covered all that there is to cover. That's not extremely complex. So hopefully it makes you understand what's going to happen this year. Maybe you can even make predictions on what's going to happen. Hold up, Andrew is actually testing me right now. All right, that seems to be it. So thanks for coming. And we will see you all on Monday when we talk about introductory, and that class will be taught by Will, and I'll be the TA, and that class will be combinations and permutations. So see you all 3 o'clock on Monday.